You've probably been told that managing Python dependencies is simple. Just chuck everything into requirements.txt, right? Well, I recently discovered this approach is fundamentally broken, and it nearly cost me an entire weekend debugging a project that worked perfectly on my machine, but would have failed spectacularly in production if we hadn't caught it in stage. Now you might be thinking, what's wrong with requirements.txt? I've been using it for years. And you're not alone. I've used it too. In fact, most Python tutorials teach this exact method. Some of you might even be doing the clever thing and running pip freeze arrow requirements.txt to capture everything. But here's what they don't tell you. When you write cryptography equals 44.0.0 in your requirements file, you're only specifying the top level package. And pip freeze, well, that just dumps your entire environment, including packages you installed for completely different projects. But cryptography doesn't work alone, it depends on CFFI and PyC parser. And here's the kicker. Each of these sub-dependencies can have conflicting version requirements, but most developers have no idea this is happening until it's too late. Let me paint you a picture of just how bad this gets. I had a project with just 17 packages in my requirements.m file. Seemed reasonable for a web application, but when I actually mapped out the sub-dependencies, would you like to guess how many packages were actually installed? 61. 61 different packages, each with their own version constraints, each potentially conflicting with each other. And the traditional requirements.txt approach gives you zero visibility into this chaos. But it gets worse. What happens when you want to update one package? Picture this scenario. You've got a working project and you decide to update one dependency. Let's say you bump pandas from version 1.5.0 to 2. Innocent enough, right? But pandas 2 now requires numpy 1.24 or higher. Your other packages, well, one of them was quietly depending on numpy 1.22. Congratulations, you've just broken your entire application, and you won't know until runtime. This is called dependency hell. But what if I told you there's a tool that solves this completely? The tool is called pip-compile and it's part of the pip-tools package. Here's how it changes everything. Instead of maintaining a requirements.txt file with specific versions, you create a requirements.in file with just your high-level dependencies, no version specified. Then you run pip-compile and it generates a proper requirements.txt file for you. But here's the brilliant bit. It locks down every single sub-dependency with exact versions and includes comments showing you why each package is needed. But that's not even the best part. The real magic happens when pip-compile detects conflicts before they break your project. That pandas scenario I just ran through, pip-compile would have caught that immediately. It either resolves it automatically or tells you exactly what the conflict was. If you found this video helpful so far, hit the like button. It really helps the channel reach more developers who need to see it. Here's what really sold me on this approach. Upgrading dependencies becomes trivial. Want to upgrade cryptography? Just run pip-compile --upgrade package cryptography, and it'll safely upgrade cryptography while ensuring all of the dependencies remain compatible. No more cross fingers when updating packages, and no more it works on my machine disasters. Your new workflow is beautifully simple. Add high-level dependencies to requirements.in. Run pip-compile to generate a requirements.txt. Commit both files to version control. Install from requirements.txt as normal. When you need updates, modify requirements.in and recompile. This gives you the best of both worlds. Simple dependency management with complete reproducibility. Your colleagues will get exactly the same package version and your production deployment will be predictable. The days of dependency hell are over. If you want to know more about writing your own packages and how to do it, you can check out this video next, top left. And with that, thanks for watching, and I'll catch you on the next one.